Okay, 5.6c, continuing with determinants and Cramer's rule. And we're going to just go into Cramer's rule without going into the theory behind it. If you want to read about the theory, it's at the bottom of page 492. But I'm going to just start with Cramer's rule for 2x2 systems. And then we'll get into larger ones here in a minute. It won't take a whole lot of time. But if we have a system of equations, so if we have a number times x plus another number times y, and that equals another number. So this would be like 2x plus 5y, oops, that needs to look like a y, equals 7. Okay, so a and b and c represent the numbers 2, 5, and 7. And then we have another system, or another number or equation that looks like this. And that would be like this. So I'm going to kind of do example 5 at the same time I'm explaining this over here. All right, so there's 3 pieces to this. One, remember how we do systems of equations? We're trying to find the x and we're trying to find y. Okay, x equals d of x over d, and y equals d of y over d. Okay? So far you don't really have to understand anything. Just look and see that this is a true statement, finding x and y. Alright, so what do we do to find d of x, and d of y? Okay, d of x. This is how you find it. You take c, c2, b1, b2, and find the minor. Okay? Just find the minor. dy equals a1, a2, c1, c2. Find the minor. D is a1, b1, a2, b2. Find the minor. Okay, and then you're going to take this and divide, and this and divide. Okay, so how does this look? All right, D is going to be first number, second number, first number, second number. That's where we get the D. D of x, we're kind of ignoring, well, we are ignoring the x. So instead of in the first column doing, the A's here, we're doing the C's. Second column stays the same. When we're finding y, first column stays the same, second column changes to C's. Okay, so whichever column we're looking at, the A column or the B column, if we're looking at the X, which is the A column, it gets the C's. Here we're looking at the B column, it gets the C's. Okay, so looking at this system right here, let's go ahead and solve this. Okay, so see if I can make some room here. I don't know if I can or not. Let's move that up here. And well, I can't really do that because in my system of equations leaves. Well, let's just see what we can do here. All right, so we're going to find our d of x, our d, and our d of y. All right, so x equals our d of x. Well, this is our d of x. So let's go ahead and write that. Our C1 is 7, and negative 3 is my C2. My B1 is 5, negative 2. So I'm looking for the minor of that. And then my D is this one over here, which is going to be 2, 5, 5, negative 2. Okay, so that gives me negative 14 minus negative 15, or plus 15. And this one's going to be negative 4 minus 25. So this is going to be 1 over negative 29. Okay? So that's what my x value is. Meaning, when I plug negative 1 over 29 in for x, it works. That's the answer for x. That's how easy it is to find x. All right, let's find y. I don't know if I can, yeah, I can't erase all this. All right, so that's my x value, and let's make that equal to x. All right, my y value is going to be d of y. I'm going to use this formula right there. Okay, so that's going to be 2, 7, 5, negative 3. And that's going to be over my d, which I really don't have to solve my d. I already solved my d once, and it was negative 29. So I don't have to do it again, because it was the same number for right here when we found our x. So it's going to be the same number here, so negative 29. So that gives me negative 6 minus 35 over negative 29, whoops, equals negative 41 over 29, or negative 29, so that means I get a plus. So my answer is negative 1 over 29 for x and 41 over 29 for y. Alright, so this is a simple way to solve a system of equations with two variables. You don't have to use elimination, you don't have to use substitution, you don't have to use that long matrix thingy that took for years. You just have to use Cramer's rule, and you can find your answer just like that. Okay, so let's do a 3x3 system, example 6, and I'm just going to write it right away into 1, negative 3, 7, 1, 1, 1, 1, negative 2, and 3. Okay, that equals D. Okay, so when you're looking at Cramer's rule for a 3x3 system, middle of page 494, it says D equals everything written in that order, ABC, ABC, ABC. So I am just going to show you how to find D here, because you find D of X, D of Y, D of Z the exact same way. Alright, so this is where we pick a row or a column. Doesn't matter which one. I'm going to pick the second one because they all have ones in them, and the ones there are going to be a lot easier. Alright, so we take 1, this one right here, times, alright, we determine whether or not it's the cofactor. We look at it whether it's positive or negative based on row 2, column 1. Row 2, column 1. Row 2, column 1. 2 plus 1 is 3. 3 is an odd number. This is going to change its sign. Then I write its minor. Remember, minor, I go, okay, just like that. So that gives me a negative 3, negative 2, 7, 3 there. Then I add. And now I'm looking at this number. And so I have a 1. And it's in row 2, column 2, so it's an even number. When I add 2 plus 2, it's not going to change the sign. My minor then is going to be 1, 7, 1, 3. Then I'm going to add this one. 1, and it's in row 2, column 3, an odd number. It's going to change its sign. So I'm just going to put a minus there to know that. And I'm going to get 1, negative 3, 1, negative 2. Okay, so let's do this part. Negative 1 times negative 3 times 3 is negative 9 minus negative 14 plus 1. 1 times 3 is 3 minus 7 minus 1, negative 2 minus negative 3. Okay, so what do we have there? That's a plus. Let's make this one a plus. This is 5. This is negative 5 times negative 1 is 5. It's 3 minus 7 is negative 4 times 1. Positive 1 is a negative 4. And this one is negative 2 plus 3 is 1. 1 times negative 1 is negative 1. Oops, this is a negative here. Sorry about that. Negative 9 plus 14 is positive 5 times negative 1 is negative 5. So negative 5 plus negative 4 plus negative 1 is a negative 10. So that's what my d equals. And then I find the d of x, d of y, d of z. And to find my x, I take d of x over d. To find my y, I take d of y over d, which I found d, so that's just going to be in the denominator of each one of these, so I don't have to do anything else there. And z is d of z over d. Okay, so I found the negative 10 that's going to go under each of these. Now I just have to find d of x, and I use it this exact same way. I'm going to look at the middle of page 494 and see that d of x is first column D, 1, 2, 3, second column B, 1, 2, 3, and third column C of 1, 2, 3. Follow this exact procedure that I did here, which that procedure is actually what we did for example 4. Okay? So anyway, that's it for 5.6.